For this problem, we're trying to find two things. We're trying to find how fast the water level is rising and how fast the radius of the water surface is changing at that moment. So first thing we're going to do is we're going to go ahead and draw a picture. We know that our tank is pointing down. We also know that the rate of change of the volume is 17 cubic centimeters per minute. We know that the height of the cone is 30 centimeters and the radius is 11 centimeters. We want to know how fast the water is rising when it is at that specific moment in time at 13 centimeters deep. So what we're going to do is we need to find my equation for all speeds, for all h's. So I'm not going to take the 13 into account yet. I'm going to write the volume. And in order to do that, I need to get rid of one of the variables. And since I need to solve for dH dt, I'm going to get rid of dr, because dr also has volume. So I'm going to get rid of the r, because I also have, it's also moving. The radius and the height are moving on the tank. So I need to get rid of one of these. So I'm going to go ahead and get rid of r using similar triangles. So I'm going to have 30 is to h as 11 is to r. And I'm going to solve for r because I want to get rid of r. So then I'm going to go ahead and substitute r into the volume equation before I take the derivative. So I haven't taken the derivative of any of this. I'm just simplifying my volume equation so I can write it in terms of r. Alright, so now that I wrote it in terms of all h's, I know I said r, but it's supposed to be in terms of h. I'm going to go ahead and take the volume. And don't forget, since this is a rate of change, we're taking, every time we take the derivative of h, it's going to be dH dt. Remember that all of these are in respect to time, so I need a dt. So here's my dH. I'm going to go ahead and substitute that specific moment in time, which is 17 cubic centimeters per minute, and h is 13. And then I'm going to go ahead and solve for dH. So solving for dH, I get 0.238 centimeters per minute. So this part B says how fast is the radius of the water surface changing at that moment. So I already have what the radius is. The radius is 1130 over h. So I'm just going to go ahead and take the derivative and substitute at that specific moment dH. So I get the rate of change of the radius is changing at 0.0873 centimeters per minute.